Let's first start by creating a logistic regression model to classify our text. This is a great model to use either as a standalone model or as a baseline model before you move on to any more complex models. We'll start by importing the packages we need, so we'll be importing the pandas package and the sklearn package. Because the sklearn package is quite large, we won't be importing all of it. Instead, we'll just be importing the selected functions that we need. So for this exercise, we'll be using a sample data set of sentences and their associated sentiment. We're looking to create an algorithm that can classify the sentence by the sentiment score. As we saw in our earlier lessons, there's various ways of computing sentiment already out there, but sometimes the accuracy just isn't enough, or you may have data that's not quite suited to the algorithms that are already out there, and you want to build your own custom model. In these next few lessons, we'll be seeing how we can do this. We've got our data set and we've got two columns. We've named them text and sentiment. The next step is just to shuffle the data to ensure we've got a nice mix of positive and negative sentiment sentences throughout the text. We'll be using data.sample with the fraction set to 1. This will just shuffle our data for us. We then want to reset the index. We'll then create our x and y to feed into the algorithm. Our x is our data text column and our y our data sentiment. We then want to do our text vectorization, and we'll be using the bag of words here using the count vectorizer function. Of course, you can also experiment with things we've covered earlier in the course, such as TF-IDF vectorization. So we'll initialize our count vectorizer and call it countVec, and then create countVec_fit and run countVec.fitTransform on our X data. We'll then create our bag of words and convert it into a pandas data frame. The column names come from countVec.getFeatureNamesOut. We can then print this bag of words to see what our data looks like. We can see each of the rows is an individual sentence in our data and each of the columns an individual word. We then want to create our train and test data for our algorithm. So we create xtrain, xtest, ytrain, and ytest. We can then use the train test split function from sklearn to split our bag of words and our y into our training and test dataset. We specify the test size to be 0.3, so 30% of our data is going to be set aside for the test data. Let's now create the logistic regression model. We'll call it LR, and then use a logistic regression function. Again, we specify our random state, and then we use .fit on xtrain and ytrain. We can then predict this against our test dataset. So we create ypred LR, and then use lr.predict on our x test that we've set aside. From this, we can then use it to compute the accuracy score using the sklearn function accuracy score. So we can look at the accuracy between our ypred LR and our ytest. We can see here the accuracy is incredibly low, so our model has not performed well at all. However, like I said, this is a really good baseline model to use before you move on to anything more complex. So this is a good baseline for us to definitely try and improve on this. We can then use the classification report and put in our test data and our predicted data to see how our algorithm works at predicting different types of tags. Let's now see if we can prove on this logistic regression with some more complex models.